Now, to set the tone, let me start with the theme itself. Reimagined exploration, advancing innovation for India's energy future, why it is so important to think differently in exploration. And for that, I would like to draw your attention on 2 points. One, India has set the target of becoming self-reliant in energy by year 2047. And that is the year coinciding with 100 years of independence of India. Second, India has also committed to be net zero by year 2070. Now these 2 points actually force us to think differently for exploration, because exploration has been always on the frontier of energy security. Another thing is that we are in an era of energy transition. So if you see the recent report from the Ministry of Power, you will find that 50% of the installed power capacity in the country is coming, nearly 50%, from the renewable, and the rest is coming from the fossil fuels. So that is why it is important to remember that we are in an era of energy transition. Exploration for India with 26 sedimentary basins, and out of these 26 sedimentary basins, only few being petroliferous so far. So exploration has to be thought by the leaders who are heading the exploration in a very different manner than what it has been done till now for the exploration in conventional ways. Challenge is not only to find hydrocarbon now, but also reimagining how we explore to maximize the value with lower carbon footprint. That's another challenge which has been added, I'll say, after so much of awareness about the global warming, climate change, etc., etc. So with easy hydrocarbons getting over, we all know that challenge is shifting to stratigraphic traps, HPHT play, subbasalt play, and deep waters. And in these challenges will demand certainly the different kind of approach. Innovative technological solutions, and we will hear from Peter Hooper that how the imaging in such kind of difficult geologically complex areas, how imaging can be improved. At the same time, global energy landscape is shifting, and in this context, exploration must deliver more efficiently with lower carbon footprint, as I said earlier. It also needs to broaden its spectrum beyond hydrocarbons by including the possibility of carbon storage and geothermal to ensure that there is sustainable energy future. Advancing innovation for India's energy future implies rethinking about the data for minimizing the risk by applying technological advancements. It also means to apply data science without losing the deep intuitional geological knowledge on which rests the success of exploration. Further, it is also needed to redesign the policy framework to encourage more exploration in frontier areas. Multi-client surveys need to be promoted, especially in the deep water, and that is where the role of regulator also comes into play, because the national oil companies by themselves are restricted to give, contracts on nomination basis. So the regulator can play a positive role in that. There could be a different fiscal regime for the frontier areas than the normal regime defined under RSC. Lastly, I'll also say that the real frontier for India is not just where, but how we reimagine exploration to deliver both hydrocarbons and low carbon future. Exploration needs to seek dual win for energy and for energy security and carbon management. If we were to reimagine exploration not as hydrocarbon hunting alone, but as subsurface intelligence building, then what we would do differently, that needs to be thought. That to do differently in technology, to do differently in our workflows, to do differently in the changing mindset of taking the things conventionally. Reimagined exploration also will encourage us to think that each exploratory well drilled is not just for oil and gas, but it is an investment in India's broader energy security. Once you start thinking that way, then probably, if that is the bottom line, then probably we'll have a very different approach, and certainly we will be playing, oil and gas companies will be playing a dominant role in achieving the India's energy security. So thank you very much for listening to me patiently, and now I'll switch over to each panelist to speak their mind on this theme. Starting with Mr. Biswanath Ghosh.
I strongly believe several parts of the Indian basins are still unexplored, and we already see that the focus is shifting to the deep water and the ultra deep water basins and the parts of the basins both in the east coast and the west coast, which is opening up for finding new hydrocarbon resources and reserves. And it is paramount that we find those resources and reserves to meet our energy demand. Now, there are three things which clearly come out as a target or a goal for us. Given that our net imports are high, we need to find more resources, need to convert them into reserves and bring them under production for the country's need. And those three things is obviously trying to find those resources and reserves. So predictability, or increasing our ability to predict better and to be within the ranges of our prediction, reducing the uncertainty and managing those risks becomes paramount and critical. The second thing would be, how do we scale it fast? I know we have been talking about it, that how do you break the cycle time? How can we move from pre-exploration to appraisal very quickly and convert what we have as undiscovered resource potential into contingent resources and move them into reserves, and maybe even bring them on production very quickly, because that is the need of the hour, and that is how we can meet our energy needs and our energy security goals and ambitions. And the third thing is being efficient and being sustainable. How do we become efficient and how we become sustainable in all the operations and activities we do? So if we consider these three things, then what are those innovations and techniques and technology happening, especially in the domains of geosciences today, which is going to change the future of the Indian E&P industry? Number one is data. The entire data, the database, the data and its elements needs to be transformed. We are all doing that in every other way we can within our operating domains, within our company, within our organization. But at a national scale, we as a community need to transform our entire data for the country. We are quite encouraged with what the regulator and the government is doing in terms of moving into a national data repository 2.0. But I think this will all come through by lifting and shifting the data into cloud systems. And the data needs to be of high fidelity, of high quality, and ready to be accessed easily and ready to be used. And those things can only come through a collaborative platform environment in a digital platform like cloud. And that's very pertinent to the topic of this conference, Rock to Cloud. So that the data is ready to be exposed to machines. So next big thing which is happening in innovation and technology these days around the digital space is high-end computing. The mathematical computing has changed the domains of how we turn around computing. And once the data framework is there, you can expose the data to the machines, and that's where all these algorithms come in, whether you call it artificial intelligence, machine learning, and you become more predictive. That is going to scale up fast, it's going to break the cycle time, and also going to help predict quicker and better. And that's when you see high-end computing at a petabyte scales are already happening. And that's how these FWIs and high-end imagings are becoming so popular and easier these days as compared to what was in the past. And you can see this numerical abilities and the crunching of the data is becoming easier. So that's a trend which I see is going to transform the way we work. And that upskilling in the knowledge also is required. The third thing which is happening specifically in the geophysical domain or in the geoscience domain is multi-scale, multi-physics computing and its approach. It's not just one piece of data sets. It's just not one piece of physical measurements here and there being taken into siloed approach which is going to churn the wheel. It is every element of geophysics, geology, geomechanics, geochemistry, all integrated together, which will, and if we can emulate the subsurface conditions to its near truth Earth model, we can predict better, reduce the uncertainty, reduce the risk, and get more resources from the large yet to finds and the potential of the Indian basins. So utilizations of potential field data, gravity, magnetics, or even electromagnetics. Include that with the seismic, high resolution seismic. Include that with the geological models and upgrade them with more learnings based on the wells being drilled. Include the geochemistry and trying to predict and move beyond the wells in the frontiers where no wells have been drilled would be the need of the hour through this multi-scale, multi-physics computing approach. That's the domain which everybody's talking about and which is taking us from a basin skills to the wiggle to even to the port throat, getting into things like even from a seismic into digital rock and trying to emulate how can a fluid move through those pores, whether it is from petroleum systems migration with the hydrocarbon moving from the source to the reservoir and getting trapped, or even within the reservoir when you try to produce even through different types of reservoir, whether they are baffled or very linear. So those domains are really transforming. And the last thing which in technology innovation is how we become more efficient and how we become sustainable. We all know that everybody is talking about CCUS. Maybe the capturing of the carbon is easier and very profitable, but maybe when you're trying to utilize it, if you don't have the fiscal systems, you'll not be able to do it better, or you'll not be incentivized to do it as a part of your business. So how we get sustainables with some efforts from the fiscals, with some efforts from the government, with incentivizing those can help us grow better. But in terms of efficiency as well, the way we do exploration, we can become more efficient if we plan better, if we have reduced downtimes, if we use technologies like nodes and other things where we don't leave a footprints behind when you do our seismic, and even if you repurpose our wells which are abundant, whether it is for geothermal or whether it is for groundwater or other critical minerals. With all these four aspects, I think that the key areas of reimagining the exploration with advancements of innovation and technology. I'll leave with that thought and we'll come back in the next round.
Thank you. Thank you, Mr. Ghosh. So now may I start from the other end. Mr. Peter Hooper, could you share your ideas about this theme?
Yeah, thank you very much. So I'll make 3 points. And you commented something similar, Mr. Dwivedi, early on. We have a fantastic toolbox becoming available to us through high compute, GPUs, new algorithms, AI, machine learning. But my first point really is that geoscience is and will remain, should remain, the foundation of innovation. Because innovation and exploration, it begins with an understanding of the regional geology, the local challenges. Whilst we have a fantastic toolbox that we can deploy new technology, it needs to be directed. So that understanding of the geology and the challenges that we're trying to resolve is a key part in input to the solution prior to releasing the power of these new technologies. Of course, when we do release machine learning, AI, there are huge benefits. It removes human bias, it removes the limitations of human training and the way we think. So it does create a much bigger landscape for innovation. However, at the end of the day, what we need to see is those results end up on the desk of a geoscientist to then make the smart decisions. The computer will not give, or the technology will not give the final answer. So geoscience, it's a core input to many of the advances that we're making in ShearWater at the moment. The first one, which I'll mention, is EFWI, so elastic FWI. There, rather than approach the Earth and the subsurface as a constrained, rigid grid and model, this technology allows us to deploy a more flexible, mesh-based model approach to the subsurface. It's better than the finite difference model, which is the previous iteration of FWI, because the mesh can adapt to the real subsurface, how the rocks actually are. It's very good at identifying boundaries, be it sediment basalt or sediment salt, ruggose seabed. But at the end of the day, geoscience is a core foundation to that technology. So I'd encourage everybody to go and listen to Rich Bartlett. He's traveled from our UK office. He'll be giving a session this afternoon at 2:30 in the technology session. about Elementi, which is our EFWI solution. Another example of this geoscience and its application to the toolbox is we must pick the right tools when we deploy, whether it's to inshore surveys or, as you mentioned, deeper water, higher volume, where we still want to see the quality as well. But geoscience is the core in allowing us to pick the right deployment of the tools. Ed Hager, who's sitting at the front here, will be giving a panel session straight after this one, where he'll be diving into, how to select the right toolbox for the right for the right problems, to address those problems. And we're seeing our client base globally mix more the types of toolbox or acquisition tools deployed. They're mixing up the toolbox a lot more. So what I expect to see more of is streamer surveys, also with nodes deployed. So you collect the volume of your data with a very efficient good cost benefit for our client survey with streamers, but we also deploy some nodes, sparse nodes at the same time to help collect those lower velocities whilst we conduct a very efficient survey. Also see the deployment of more low frequency sources, which is another key element to us collecting those low frequencies, without which, the EFWI or whichever mode of FWI you've deployed will not be as effective. So that's my first point. Geoscience has to stay key. Second point is that survey design matters. So you must have a survey design which is tailored to the challenges which you're trying to resolve. And back to the geoscience, you need to understand what challenges to expect to deploy the right toolkit. Copy-paste approaches where we don't think enough will not give you the best results. It'll be suboptimal. Yesterday, Arenze, one of our really talented geoscientists, travelled also from the UK. He gave a talk about India's sub-basalt challenges on the west coast. And I think if you saw that, or if you catch up and read the slides, you'll see that what his real reflection is, it highlights that even though the toolbox improves, we have fantastic compute, fantastic AI and machine learning available, you need the right data. If you collect the wrong data, those tools can't fix that. You can't recreate low frequencies. If you don't have enough signal to noise at low frequencies, that might be offset. You might not have enough offset. It might be that you didn't use the correct source. Then you're fighting a losing battle before you start. We see already India starting to adopt and see this is needed. I think his conclusion yesterday was you probably need 16 to 25 kilometer offset to really solve the basalt and see underneath. That means multi-vessel operations. We see ONGC, DGH consistently opening the bar when it comes to offset and streamer length. The right thing to do. Perhaps not in shallow water, right? It's very difficult to tow 12 kilometer offsets where there's hundreds of fishing boats around. But survey design is key, and I think we'll see more multi-vessel requirements to solve some of these geophysical challenges. And if you do that right, then you have better low frequencies, you get better inversion, you get better velocity estimation, and your FWI product will be superior. Third point is, and you mentioned it, Mr. Dwivedi, as well, larger surveys they help and they are enablers for innovation. Typically in India, we shoot, I wouldn't call them postage stamp surveys, but we shoot lots of small surveys where it's really an asset or a budget which is setting a small survey, which is quite inefficient from a cost perspective, but it also doesn't leave enough room for innovation. We typically see on a large survey where you know you're going to be in one location for a long time, you can also project a development plan and test some parameters, perhaps test a different source, and within the bounds of a larger survey, still choose to elect to deploy that later on. So I think there's a lot of room when it comes to survey contracting, when it comes to both the volume, but also the thought and the collaboration that goes into the survey design. We need to talk more. We need to connect the right people within the Indian oil companies and at DGH with our geoscientists to make sure that we deliver the best product. So that's my 3 main points, I think, on that topic.
Thank you. Thank you, Peter.
The situation in which India's energy requirement and India's energy's future is there, it is very different from other places in the world. How this energy requirement current and what is projected It cannot be met by our routine or legacy, I should not say legacy, routine exploration in, approach. It cannot be incremental, it has to be a significant jump. Then only we will be able to address the energy future requirements. How we can do this? You see, the exploration reimagined, definitely we have to go aggressively in the frontier areas which we see and which we feel is relatively less explored. At the same time, the infrastructure-led exploration, which by and large has been our main focus areas, has to continue to support the incremental additions to our producing fields. So we have to make a fine balance, and in today's world when we operate in say around $60-65 per barrel of environment, which is likely to continue in the near future, exploration activities has to be very, very focused, very, very cost effective and in a compressed time manner. So here the opportunities are there that a lot of advancements, as Mr. Ghosh mentioned, Mr. Peter also indicated, that the inclusion of AI and ML approaches in our E&P activities has to be pursued very, very rigorously. The manpower has to be, I see that today's geoscientists has to be in hybrid mode. They have very, very strong fundamentals of our geosciences, but the data science part of it has to be amalgamated in a much stronger way, much faster way. This is going to enable us in a fast happening exploration regime, and this is going to help, or this is going to definitely address our quick exploration requirements. Now, there are many enablers. I will just point, as far as ONGC is concerned, we have joined a data platform called OSDU, where I think 100 plus companies have already joined. So we will be able to make our data amenable to AI/ML applications, and we can quickly take the benefit of the vast data which we have to decipher more precisely with more definitive tools in our exploration portfolio. Now, the second part that is also becoming very important is the policy support which we are seeing now is evolving gradually and more on a stronger foot. You see, deep water exploration or ultra deep water exploration, any operator cannot take it very aggressively unless because of its cost, so capital intensive. But now there is a signal that yes, the government is coming up with some support so that the operators can go aggressively in those areas. This is one part. Second part, I can definitely see that in future, the hub type of development, I see that Mahanadi, which ONGC has discoveries, other operators also have discovered fields, but we are not able to monetize because of standalone development, may not be feasible as of now. But I see that collaborative infrastructure approach, those discoveries we can definitely bring for monetization in a quicker time frame. There are other climate-related concerns also, but being a geoscientific fraternity, we have the advantage also. Today, there may not be a commercial model available for decarbonizing the emissions which we are having, but we have the understanding, we have the knowledge of the subsurface, which in future we can use it for storing CO2s. When we drill in a wildcat area, category 2-3 basins, suppose our wells are not found to be hydrocarbon bearing, we can repurpose those dry wells or wells for looking for suitable aquifers, because aquifers they hold huge potential for storing CO2. So we can repurpose our exploration, not only limited to oil and gas, we can repurpose for storage of CO2, and time is going to come when this will become a very attractive commercial model in the times to come. India being almost third largest CO2 emitter in the world. So that angle also, exploration fraternity, geoscientific fraternity has an edge. We can immediately convert this into opportunity for commercial interest as well. Many depleted reservoirs. One of I can see that, say, for example, Basin field, which is on declining phase, after say 8 or 10 years, it can become a good storage candidate for CO2 in offshore. So this kind of thoughts or this kind of situations is going to arise where this geoscientific community can repurpose and reimagine to the benefit of India's energy future, India's energy requirements. So these are some of the thoughts I thought I must put before the audience. Yes, thank you.
Thank you, Mr. Sinha.
Well, it's very interesting to see that this topic, Exploration Reimagined. Quite a few years back, we had a similar topic for I'm speaking from Oil India's side, so I'm taking Oil India's example. We had this exercise done across the company where we said that since Assam is our main producing area, so we had this exercise done called Reimagine the Main Producing Area. So if you want to reimagine it and you want to see what the future lies, what activities need to be done. And so very aptly, I'm very pleased to see this word coming here again in exploration especially, where it's advancing innovation for India's energy security and future. But, well, fundamentally, seismic is the key for exploration. But then this is where I think that's where we can have integration and multiple analysis done. Very fundamental of everybody knows it. So and this is what we have been practicing as well. For example, we have done extensive airborne gravity gradiometry. Our plan currently is to actually in the northeastern part of the country where logistic and terrain is a challenge for acquiring seismic. We do plan to cover the entire northeast with EGG data, maybe 40 or 50,000 square flight line kilometers. We have already acquired substantial data, and very interestingly, in the North Bank, these are practical examples I wish to share with everyone, where we have only one 2D line, and based on that 2D line integrated with EGG data, we have even boiled it down to prospective location for drilling. So these are the sort of new things which we really need to incorporate in today's world, and that we are doing. We have done quite a significant amount of PST, and we have integrated PST data with seismic as well. And then we have also integrated low frequency passive seismic, which is a direct hydrocarbon indicator. We have been very encouraged with the results that we have seen from LFPS. So integration of that along with again seismic. These are going to be, and I don't know what sort of other innovations we can bring in, but there's one thing that we have also done in the recent past is we have merged all our 3D data. So this 3D data vintage dates back from 1993 to 2023. So this entire data we have merged. This covers close to about 30 seismic blocks, and the entire gamut of data that has gone in there is about 4,000 square kilometers. So the entire main producing area in the northeast where we are working on is now having one single 3D pre-stacked data, and that is definitely going to add a lot of value for exploration. And then we are going to integrate this with the petroleum system modeling, which is being done for the entire area. So you cannot reimagine, I think, more than this in terms of today's conditions. But apart from that, in order to bring in innovation, there are a few other initiatives that we have also undertaken. For example, we have introduced the technology induction board in the company. So whoever is coming with whatever technology, whether it is proprietary or patented or unique, everybody can apply, and the response period is just 1 month for us to get back to that. We have, in order to bring in digitalization and innovation, we have embarked on a program called Drive 2.0. Drive is short for Digital Readiness, Innovation and Value in Exploration. So that is a full form of Drive. So Drive 1.0, we had quite good success. And in Drive 2.0, we are going to go all out in implementing digital solutions for, especially in exploration. We have already initiated in some areas. For example, even in safety, we have introduced digitalization so that using AI, ML, we can see whether people are using PPEs or not and what unsafe acts are being done. So these are a lot of areas where innovations can still be brought in exploration. But one key component, of course, is collaboration with the best of the best institutes, collaborations with the best of the best multinationals, international oil companies. We have been successful in that as well. Everybody knows we already have a technical service agreement with even with Total, and we are pursuing this with other MNCs and IOCs as well. But it wouldn't be fair enough if we don't bring in the cost component into this concept. Because when we are staring at a $60 per barrel world, that also has to be brought into the equation. And that's the reason why in every engagement or in every work that we embark on, time is of essence. And things have to be done on time, decisions have to be taken on time. And that's why again in oil, in my company, we have initiated this process of cost optimization. We are not saying cost cutting. We are not going to cut costs anywhere. What we are saying is we are going to optimize on costs and what are the areas where we can optimize. So this is not, again, a cost cutting exercise per se. Nothing is going to be cut. And we are already looking at numbers and the processes where we can do this cost optimization as well. So I could go on and on, but innovations, I was just talking to Dwivedi sir here in the morning while we were sipping coffee. And for example, in one of the OLP blocks that we have recently acquired, there is a substantial amount of legacy data. Of course, we bid it along with additional 2D and 3D data and wells. And so we are now trying to see what different way we can do immediately so that things can be done differently as well. You don't have to do different things, you just have to do it differently. So what we are going to do is as soon as the PL is available, we are going to spud the first and the second wells and then take seismic and then tie up the well data with the seismic again. Because even the wells that we have boiled down to, we are sure that we are pretty much confident that we will strike hydrocarbon in that well. So these are the sort of things that we are trying to work on. We are trying to innovate within our own organization, within our own self, and take this forward. Thank you very much, sir.
Thank you. Thank you so much in the success of exploratory well, because if the drilling is efficiently done, then obviously the exploration succeeds. So could you share your thoughts about this theme?
So taking clue from Dwivedi Saab's speech, opening speech, it's 2047 and 2070. So our nation is an energy-hungry nation, 5 MB per day, moving linearly up, but renewable energy already 50 half of the capacity of target we have already achieved. So we are not the nation which professes only drill, baby drill. We are also for the renewable energy. And I'm sure that with the manner in which our RE is going up, that curve of this oil demand will definitely dip one day. Because now coming back to exploration, of course, seismic, what I can understand very clearly is that now we are in an age where AI and ML has come. So reimagining exploration, the first and foremost which our company is already doing is handling the capacity to handle a lot of data has now increased a lot. And with so many young minds in our company, besides the seismic acquisition and finally processing the time is going down, we have technologies where simultaneously acquisition and processing is going on. So that era has come. Coming back to exploration, first and foremost is for energy transition, which is policy of our nation and of our company also. Energy transition, we need money. And seeing the needs of the nation, the demand for the oil and gas, definitely the money is coming from the exploration and all our brownfields. The first and foremost is how we control our decline. And like Sinha told, ILX-based hydrocarbon exploration is also one of the key for us, and in Western Offshore, we have got good success. In many of the already established fields, we have got some good find. So coming back to reimagining world in exploration, I can understand that due to our AI/ML enhancement of capacities, we are also looking forward to reprocessing our old data. And in our, I think in our Ankleshwar assets, we have come up with new locations also from the old data, if I'm right, Sinha. So you can see how things are changing now. Again, like this word India's energy future, we are leveraging our exploration skills in geothermal also. In Puga, we have drilled one of the deepest wells. Although it's not conclusive, we could case it up to a particular depth. We used our capacity in our skills and knowledge in exploration and used there. And as you all know, world over geothermal is a zero carbon industry and a lot of potential for that. So that beginning has also started. Then coming back to deep water, a lot of capex is involved. So collaboration is very important. Now that government policies are changing and they are supporting us, so in the deep water exploration front, so collaboration and joint ventures is also very important. So my view is that besides our already established fields, we have to use our skills in latest technology upgradation in AI/ML, in reprocessing our data and going aggressively for arresting the decline in our brownfields. Coming back to our oil and gas hydrocarbon industry, it's a highly carbon intensive industry. So the first target is low carbonization pathways. We already have new generation rigs where we are using gas for the power generation. In many of the assets like Tripura, we are full of gas. There we are already going for, so that's a considerable cost reduction there. Then of course, gas flaring, we are working in a big way. We are reducing it, and I think we have come down to 2-3% all in our installation. And wastewater utilization, we have also come a big way. So similarly, going for exploration, working for the renewable energy and going low carbonization way is our main motto and vision of our company. And we are going, our plans are built in that way also. Coming like Dwivedi sir just now asked about drilling efficiency. So already we have our real-time data center at Dehradun, where we are monitoring all our operations online, real-time, throughout the year, throughout 24/7. And we are avoiding lots of well complications. We are improving our drilling efficiency. So that way we are going very fast in that field. And now we are coming out with the new phase, sir. So that way we'll be covering HPHT wells and offshore also and at one place. So now we are moving our well designing and well completion part also to our center rate therapy. So that is the our aim and how we are going to reposition ourselves in this industry. Thank you, sir.
Thank you. So we'll be seeking your opinion on seismic imaging in complex geological setup like sub-basalt, sub-thrust and deeper plays. So what game-changing technologies you think are ready for a scale deployment in India?
Okay, thank you. Good question. I think I've already mentioned several of them when it comes to AI, EFWI, machine learning, survey design. Maybe I can mention a couple of breakthroughs and tools and innovation which ShearWater are currently deploying to the market. And the good news is some of these tools are already being adopted in India quite quickly, despite what I said about quite rigid contracting processes in India. One example is the commercialization of our new Pearl node. And your question was about imaging, but back to my comment earlier on, you need the right data to produce the best image. So we've recently launched a new node, the Pearl node, which is MEMS based. So it records acceleration, but there's also a fantastic hydrophone in the instrumentation. The hydrophone goes all the way down to half a hertz. It's probably industry leading when it comes to the low frequency, at least on the receiver side. ONGC actually adopted that hardware last year on a survey in the KG Basin on the east coast. We're not processing the data, but we did the QC, and I imagine that the data looks fantastic based on what we see, and that's a direct input to fantastic imaging, right? Is the right measurement or the best measurement. Another innovation there that actually allows us to do that in a cost-efficient way, which is back to my colleague's comment about cost is also always should be part of this discussion. So that data was acquired using a technology platform, the ShearWater Tasman, 2 ROVs, very appropriate vehicles, and also on board the vessel we have, of course, our onboard processing capabilities. So for us, the imaging and the processing starts on board the vessel. It shouldn't start when the tapes hit the processing center, a long way from the actual operation. One challenge back to India there, though, is that it's fair enough to say that, yes, we have big data lakes in India now starting to build. You have good connectivity to your fixed platforms, perhaps through fiber optics or copper wire, but we're not going to get from the rock to the cloud using copper wire when we have a vessel which is hundreds of kilometers offshore. So one area that we see innovation happening elsewhere in the world, an example in West Africa recently, we were running a project with 6 Starlink antennas, 6 full Starlink units on board the vessel. I think that's a challenge for India that policy needs to address, and it's linked to MOD and it's linked to national security and what kind of communications are allowed in the country. But typically when we come to India, we have to swap the VSAT out for a local system, and if we don't get the bandwidth, we can't perform with these new tools. So I think that's definitely an area where the oil companies and policymakers should look, is how do we enable offshore communications that allow the deployment, as you were saying, to allow your teams onshore to visibly see the data in real time and interact with it and project competence offshore to the vessel. That's definitely an area where it's ready, but India needs to be ready to receive when it comes to that kind of satellite technology. Yeah.
Another question for you, Peter, that with the ESG compliances mounting, how can service companies ensure that exploration operations have lower carbon footprint while maintaining high resolution and data quality?
Okay, another good question. So before I dive into the ESG part, many people might not be aware, but of all the countries in the world where we regularly operate, we have a huge impact, not just ShearWater, but whether our clients, Oil India or ONGC, We collect and clean up a lot of debris offshore. It's probably the world's most expensive vacuum cleaner if you put a big 3D boat out there to pick up fishing gear. But we collect hundreds and hundreds of tons of lost equipment, which kills turtles, it damages fish stocks, and we deliver that responsibly onshore to be disposed of. That's a very India-specific contribution, I would say, driven by our high volume of operations. As a company, we're very committed to safeguarding the environment that we work in, and that includes the people that work and live in that environment. It's quite often the case when we were close to shore, right? A lot of third-party interaction with fishermen, people who also make a living from the marine environment. So we take that very seriously. We intend to leave the environment at least as well as it was when we arrived. Within ShearWater, there's no way around the fact that the most cost-efficient surveys are streamer. And to do that efficiently, you need a lot of power. You use large engines because you tow big spreads. So they are very intensive when it comes to fuel usage. But there is actually quite a lot we can do about that. So our targets, whilst none of our targets individually contribute more than 10% reduction, collectively they can reduce by tens of percent. And I'll give you a few examples. One is we concentrate on the fairings and the hydrodynamic efficiency of the equipment we tow. So that means streamlined equipment that creates less drag. There's quite a lot of savings there. We also focus on the engine room and the way we manage the engine room on our vessels, because if you have, can I say this? If you have lazy engineers, it's not very politically correct, but if you want to run your maintenance so that all the engines have the same maintenance interval, then you run them all with the same hours, because then everything gets changed at the same time. We're very focused on not allowing that to happen, so that we run with the best, highest load, but without excess power being deployed. And also small things, like our factory in Malaysia in Penang, they've changed from diesel forklift trucks to electric forklift trucks. So every single thing you do counts, but a lot of it's down to the marine maintenance, the way you run your engine room, polished propellers, adopting new technology which reduces your fuel burn.
Thank you, Peter. Now coming to Mr. Saloma Yomdo, I have two questions. So first is that as India pushes for self-reliance in energy while pursuing net zero emission, how do you propose to balance frontier exploration versus redevelopment of mature basins?
Actually, these are both interlinked in the sense that when you have a mature field, one of the key things that we generally also do is near field exploration. So rank exploration is one. But then the near field exploration part of it is equally important to us because that is what's going to bring your reserves replacement ratio to balance the reserves replacement ratio. So near field exploration is very, very critical for us for maintaining the reserves replacement ratio, or even improving the reserves replacement ratio, or increasing the R/P ratio, the reserves to production ratio. And and in order to invest in rank exploration or near field exploration, it's paramount critical that your mature fields don't die off soon, so that you have sufficient revenue stream to continue your E&P activities. Well, fortunately, in Oil India, we have been able to maintain our levels of production. Actually, in the recent past, we have increased our production from the mature fields, even though there is an average 10% decline in individual reservoirs. But still, on top of that, we are being able to maintain a 3 to 5% year-on-year increase in oil and gas production. So that's actually how it balances out. And most of that is actually through induction of, as I think it was written in my resume as well, fit-for-purpose technology and various improved oil recovery and enhanced oil recovery measures. And that's the reason why we have we have been able to achieve recovery factors in excess of 40 to 50% in majority of our reservoirs. But that has to be more balanced, and for that we are actually on a very aggressive path. For example, the numbers are there for everyone to see. 3 to 4 years ago, our acreage was less than 50,000 square kilometers. Today, our acreage is over 100,000 square kilometers. And exactly now what I'm saying about Oil India, that where we are and what we are doing currently, this is unprecedented for the company, and we are all proud to be a part of it. This is totally unprecedented, and we are gearing ourselves up for this, and hopefully with that, our exploration and production numbers will significantly improve in the long run. Thanks.
So another question is, you talked about the integration approach using seismic along in the airborne gravity and other data sets. Have you thought of collaborating with the ONGC also in terms of further integration of data? Because within the company it is fine, but what about your adjacent acreages? ONGC has the acreage. So can you think of collaborative model, or do you have in plan, or could you share your idea about that?
Sir, this has been one of my dreams to collaborate with ONGC. In our earlier capacities, when I was heading Center of Excellence and all, we used to collaborate a lot with institutes like IRS, even with IDT and IP, and IOGPT as well. With them as well, we have collaborated a lot. But now, seriously, we want to take it a step further. And that's the reason, sir, in OLP9, you'll be happy to note that we have collaborated with ONGC, we discussed together, and we zeroed down upon 3 blocks of mutual interest, and where we are actually 50-50. So we are in KG offshore, we are in Meghalaya, we are in Kembe, together with ONGC, and we acknowledge ONGC's experience and expertise in these areas, and that's the reason why taking a leaf out of ONGC as our, I would say, I always say ONGC as an older brother. So taking a leaf out from them, we have made a lot of strides and improvements. And definitely, sir, collaboration is one thing which I mentioned in my previous opening remark. And collaboration with ONGC is also one of my dreams that we would like to carry forward.
Yeah, I mean, but then my question was specific to data integration. The data which Oil India has in its acreages and adjacent acreages, the data which is purchased by ONGC. So how to think about integrating that data and then coming out with new wisdom, new insights for further exploration in Northeast India?
Yeah, I think, sir, that is also going to happen, because now DGH has undertaken the hydrocarbon resource assessment study 2025 newly. So all the data will be integrated, because in the steering committee and in the technical committee, ONGC and oil representatives are there. So we will have access to this data now, courtesy of the hydrocarbon resource assessment study coming up.
Thank you. Now, Mr. Saxena, I have a few questions for you as well. You said ONGC is heading towards digital transformation using AI, ML, and deep learning. But it is also said that the digital transformation for a company needs 10% efforts on algorithms, 20% on infrastructure, and 70% on people. Now, how are you planning to address this change of mindset in the workforce for preparing them for this digital transformation?
So rightly said, the main foundation of ensuring a smooth and productive digital transformation are our human resources. So we are going in a big way in digital transformation, and we have, besides the regular trainings, and we have created lots of platforms for our youngsters to empower them. Like we have this Udbhav hackathon we recently had. We had around 1,000 young officers participating in that, and they came out with around 12, 13 very good use cases, and we have already implemented those use cases in our operations. And besides that, we have learning management systems. We have one program, Karm Yogi, where we are giving them full-fledged in training to all. Plus, through our Unnati Shikhar succession planning program, we have zeroed down to around 60 young senior officers, and they are also working on different digital projects. So, this spirit of digital transformation is all through our organization going on a very fast pace.
One more question. You talked about real-time data centers. So can real-time geomechanical updates guide drilling decisions in HPHT wells?
Sir, what you said is definitely very much relevant for HPHT wells. Like in past, we had some static geo models where we used to work on them and then we used to go for drilling. Now that new techniques like MWD, LWD have come up. So drilling with these techniques in HPHT wells have really helped us a lot, because we can do our dynamic planning along with the drilling going on. And the main issue is the very narrow window between pore pressure and the fracture gradient. So managing that is paramount to us. And through these new technologies, MWD, LWD, and of course the real-time monitoring, we are able to change our strategies dynamically. And we are able to drill these wells successfully. Especially recently, we drilled a well in Andaman. We could successfully complete it. It is around 5,000 meters of depth, sir. And through our very close planning through real time, and of course this LWD and measurement while drilling techniques, we could drill that well successfully, sir.
Thank you. Coming to you, Mr. O.P. Sinha, I talked about the dual win for exploration, and wherein exploration not only helps energy security, but also in terms of lowering the carbon footprints. CO2 EOR offers an opportunity in this direction. So, could you share your experience in this area, especially for the ONGC matured fields, if their effort is made, and is there any roadmap drawn for CO2 EOR?
Sir, CO2 is a very, very interesting fluid, sir. In our mature fields, for example, some of the sands in Gandhar we have already recovered 30-35%. CO2 still holds a promise for additional oil there. Just because CO2 can be converted to liquid form in supercritical form in a very, very at comparatively less pressure and temperature. In our depleted fields in Gandhar, some of the reservoirs, we find CO2 is still can be injected in miscible form. So miscibility is very, very important factor when we consider for any EOR schemes. So in depleted reservoirs, there are certain reservoirs where still CO2 can be used for displacing the remaining oil. In fact, we had, in your time also, sir, we had a collaboration with one of the IOCs, where we wanted to source the CO2 from their the refineries to take it to Gandhar field. But the project was conceived, from technical point of view, it's a successful process, I will say, but it could not be launched because of economics. The challenge was that we require a long pipeline connecting to the source and sink, and that pipeline bears a huge cost. And the other end where the source is there, we need to capture CO2 from that, and the capture cost is very huge. So any company any operator will not is not ready to invest that much amount of capital in capturing CO2 in today's scenario where the industry is free to emit CO2 in the atmosphere. So
Yeah,
once
Yeah, but I read somewhere that Wager Field in Canada,
yes,
they increased the efficiency by, the recovery factor by 16% by using CO2 EUR, and of course there was support from the government.
yes, sir. So,
And here probably that is one area which calls for,
yes,
reimagination by the policymakers.
yes, yes.
So, unfortunately, there is no policymaker here representing, but that's...
We approached to Niti Aayog also, sir. We proposed that let us see how it can be, the viability gap funding can be worked out. One area we suggested that the pipeline which is bearing a huge cost, let us not load entire cost on this project. Let it be a sort of infrastructure where, because in Western sector there are a lot of CO2 sources. So let a customer can use this infrastructure pipeline, hook his CO2 source, and it can be transported. That was one part. Second, the CO2 we were supposed to purchase and inject. So that is also a very, very difficult situation because the economics was working out to be around $100 per barrel. If we really purchase CO2 and inject it, so in today's world it appears very funny that we have to purchase CO2 and inject. So we also suggested that you waive off the purchase price. But things are anyway, the project technically perfect. It has lot of potential, 10 to 12%, 14% additional oil could be there. So seeing the economic hurdle, we are planning to, we have identified a smaller project where we can demonstrate, because we have moved beyond R&D in this area, sir. We have moved beyond R&D. We need to demonstrate that a small project can be commissioned, can be operationalized. So in that direction, sir, we have designed a small project where we can source CO2 from nearby places in the range of 80 to 100 tons per day. The Gandhar project was 1500 tons per day. So this is 18 to 100 tons per day, and we will store it. May not be for your purpose, but we can demonstrate that yes, it can be stored safely. So once this will give confidence to our policymakers also, yes, when we can capture and store CO2 safely, then some policy matters can evolve, sir.
Great.
So in this direction, we have submitted some documents also to Niti Aayog. And sir, in HPHT reservoirs, we don't see any, the challenge remains basically in the how to frag them, because those the HPHT reservoirs which we have, they are relatively tight. So the challenge is to frag the HPHT reservoir at those temperatures, and another challenge is the availability of frag fluid of that rating. So these two things are hampering. Otherwise, in normal tight reservoirs, there have been a lot of progress, I would say, in terms of characterization. We are able to characterize, find out the sweet spots, and also in many fields in the Rajamundry asset, and we are able to successfully hydrofrag the tight reservoirs, and the production has increased to the tune of 7 to 8 folds in the initial phase, and it is sustaining at least 4 to 5 folds higher. So HF has really turned around some of the fields in Rajamundry, and in Nagalanka with Vedanta, we had done very, very high tonnage jobs, and those are very successful jobs. The next target is, because in Rajamundry southern sector, we have thick sands. Thickness is no issue, there is no water, so we can do very high tonnage jobs safely. now we are focusing in the western sector where we struggle with the presence of coal. So there we have to, the HF design has to be very precise. The HF load has to be very precise so that the job is successful. Another new area in terms of, I will not say no new area, it's a Chatral sands of in the western sector, they are holding huge reserves, sir, and the recovery is still very in single digit. So multi-stage hydrofracturing in horizontal wells. So 2 or 3 wells are lined up, and in couple of months we will be able to drill horizontal wells in tight reservoirs with multi-stage frac. So we will evaluate those, and if successful in terms of again economics and the additional oil, then we can expand it to in these reservoirs.
Thank you.
Yeah,
Thank you. Lastly, Mr. Ghosh, while several sedimentary basins remain underexplored, how should one think about basin screening and risk assessment if the exploration has to be, fast-tracked?
I think the most important aspect which I mentioned before when I was doing my first round was availability of data and analyzing the data itself. So screening of large scale areas within multiple basins would require seamless data availability. So while a lot of data is available in our data repositories, but a seamless amount of data is very crucial. That's where multi-client databases and multi-client data acquisitions and data availability comes handy, because the multi-client service providers provide better fidelity of the data itself, even can rejuvenate the existing data when reprocessed as well, and that allows quick screening. Large-scale petroleum systems modeling studies, which the regulator themselves are doing in terms of resource assessment study, but in terms of having these a priori studies, geoscientific integration studies already done based on the existing data, not only the seismic, the wells, and any other rock records which might have been analyzed in the past, if it's published and integrated and available at a large scale, that will augment and fast track a lot of a priori exploration, even pre-bidding or even pre-activities of doing more surveys or taking up more exploration activities. This happens all over the world. If you see, again, an example from West Africa, large amount of those West African basins are already covered by seismic, which is rejuvenated by either reprocessing or reimaging or through multi-client services. Even you have repositories of non-seismic data as well available in the domain, which different bidders and operators can purchase upfront before getting into a bid round or even getting into a block. And with that, what it does is fast tracks a lot of the exploration activities. I think we need to bring that approach into India.
True. And one more question. So what kind of advanced technological solutions and innovative approach is made by your company, especially for Barmer Basin, where you have several fields? So could you just tell in a minute or two?
Yeah, before coming to Barmer, I'll tell Kane Oil and Gas has been pushing a lot of innovation and technology over last 3 decades in the country. Whether you look at the 4D seismic in Rava, where it helped us to increase the production, and even 95 bypassed oil, or even moving into the spectral domains to relook into the seismics in the Cambay offshore, where we transformed the Lakshmi Gauri fields from being a gas field to an oil field, because oil was never seen because everything was masked by the gas above, and we could at least extract that oil from the Tarkesha fields. Even getting into newer areas like Barmer, when we had that belief and continued with our seismic programs, drill the wells toward the north. But the key things which actually helped augment a lot of things which we were doing in Barmer was acquiring good quality data. So over the field, the northern fields of Barmer, we have very high density data. We have merged all our 3D together. We have a mega merge, like I think others were talking about, where you can seamlessly grow from a seismic scale to a reservoir scale by doing inversion products. We have technologies and innovations in the tight reservoirs of Barmer basins, wherein we apply microseismic techniques and technologies to monitor our fracturing as it progresses and improve and augment our tight reservoir deliverability. What we have also done recently is we have integrated all our wells, and both from the exploration, appraisal, and development, integrated our seismic, integrated all our petrophysical information, and we have created our own petroleum systems modeling, which we are also in the process of upgrading with new geochemistry and analysis. And that's very critical because that has helped us identify subgrabens within the basin which hold huge unconventional and tight reservoir potential. And we have undertaken basin-centered drilling, trying to check on those unconventional potentials, and we're getting positive results. I'd like to also touch upon going a bit beyond Barmer is something which we're doing very uniquely now. We are focused towards deep water. We have successfully utilized control source electromagnetic surveys and data as well, and that has also helped us in identifying sweet spots within our block in the deeper water. And these sort of techniques help. And again, swinging back around some of the potential field data which I was talking about, like what Saloma was also mentioning on, was large-scale potential field data. We also acquired 40,000 square kilometers of large-scale, one of the largest campaign of airborne FTG and magnetic data. That helped us also in Barmer, in Cambay, in Kutch, and in SM Arakan, identifying and integrating that with the seismic we have, identifying the sweet spots. So Kane has been playing a very important role, and we are doing that. Since you touched very briefly upon some of these ESG elements, I'll briefly also touch upon what we are doing in Barmer. We with our partners of Baker Hughes and Dastur Energy also undertook efforts to see how we can apply CCUS and even utilize waste to energy technology options. We see very positive results in those. Again, commerciality and economics play a role. Policies and relaxation policies, how you trade credits around those space is important. But we clearly see 1.8 to 2 million metric tons of CO2 can be offset very easily from the fields and operations in Barmer.